Oh, hello. Welcome back to Make It and Break It. My name's Andrew, and this is our Project HyperTenere Yamaha R6. We're back here at the front. Last time you saw the front of this bike was probably when we were putting these bright orange thingies on. These are our new brake lines from Spiegler. Really good units, and I managed not to friction weld a washer to the nut this time, so yay me. But we're back here at the front to deal with some of the other stuff that should be here and isn't. Specifically, the stuff that goes right here normally. Now that stuff is our headlight assembly, our speedo, our instrument cluster, and actually our intakes actually come out all the way up in front of here and kind of end up right up above our horn assembly right here. So we're going to adjust all of this to accommodate for a couple things. One, the fairing that we had somewhere, I took it off already, really wasn't going to clear this. We would have to cut it off, and that wouldn't look the best. I mean, I'm not expecting perfection here. This is a rough and tumble bike when you come down to it, but it wasn't going to look amazing. But we would have to cut it in order to clear the handlebars to get through a full rotation. We were actually contacting as the fairing came up and over on the bubble shield. So that would have to go. And it just didn't sound fun to keep the old front end since we're changing a lot of everything else about this bike. So instead of a giant assembly like this sitting out front with the fairly distinctive R6 front headlights, we're going to basically strip this entire thing down to its aluminum frame, which is kind of these parts that everything bolts onto, and get a much simpler, more rally style assembly with some new headlights. So we sourced two set of these 6-inch LED headlights from a company called Diode Dynamics. I'm really excited to try these out. They look really cool, and these are going to sit, as you might have seen in the style, somewhere right about here on top of each other. Let's get the second one out. Like this. So we're going to have a double stack of rally style headlights. So these headlights are really cool in that in a very similar housing we actually have two completely different headlights. This bottom one is an SAE style headlight from them. This top one is a flood style. So we're going to have this top one hooked up to our high beam switch for riding in the woods or other places where a much wider angle of view, much wider field of view might be nice. At nights on back roads when you're worried about deer, that sort of stuff. So we're going to try and get a much more low-key front end going on this bike. So first, we're going to have to disassemble this front end and see what she looks like. Alright, so we've done a little disassembly, and I put it back on to kind of mock up things here and see what they look like. And I'm not a big fan of how things sit right now, personally. I did pull this headlight off. This is a stock 99 or 2002. There was some upgrades done on this thing to put it up into like a 2002 sort of color scheme. I don't remember if the headlights changed at all at that point. But we pulled the headlights off. These things are still good. I'm probably going to sell them on eBay or locally or whatever. But these are off. But these would normally sit somewhere right around in here, right? So that we're going to pull these off and leave them off, because if we just left all this on without a front fairing, we'd look a lot like an Aprilia Tuono, and those are pretty ugly bikes when it comes down to it. So we don't want any of that. And that comes to the second thing here, is that even with that off, if we leave this intake system on, so this is the stock R6 intake. It's like a semi-ram air intake. The idea is if you get a lot of fast-moving air coming in front of here, like when you're going pretty high up on the rev range on a track or something like that, which is where this bike is designed to live, you get a ram air effect. Essentially, it acts like a mini supercharger. The air pushes in faster than the engine's taking it in, so it builds up pressure, which allows it to force more air into the cylinder. Like a supercharger or a turbocharger, except it's just a function of the speed of the bike. But if we leave this on, this thing's still going to extend out this far. It becomes really long, and we have to start getting crazy with this front fairing in order to fit everything. And that, honestly, that just doesn't sound appealing to me. nothing about this intake I really love aesthetically. And I mean, I think this bike would look better if we shortened up the front end a little bit, shortened up actually all of it, and probably shortened up the passenger side as well. But up here, I really do want to shorten and squeeze this up. So I think this looks a lot better. So you can see this is so much shorter, and it's nice because now when we go put a light up, this light doesn't have to extend here or sink back into a fairing that's here when your air intake's somewhere out here, right? So you get to shorten up the bike, and I think it's going to look a lot cleaner when we're done with it because there's fewer things for us to cover up and screw up, especially when you're fabricating at home. That's a definite bonus. So I think what we're going to do is, I think we've stumbled into our build concept, which is a street fighter with dirt tires and a skid plate. Which I think is actually a pretty good description of what we're building right now, except for the back end, at some point we'll start getting luggage racks filled out. But this is basically a street fighter build. So you take off your front intake, ram air intake system, shortens everything up, and then new updated headlights. In this case, we're going to run 2 LEDs, showing you that earlier in this episode, I think. I don't know, I'm filming all this stuff way out of order, so my head's all over the place. What we need to do now that we've figured out what we're going to do, is basically throw away the entire front end except for the instrument cluster, which we'll have to mount. We have to figure out a new mount here that will allow us to mount both of our headlight setups and our instruments up here, and hopefully let us put some sort of like maybe mini Dakar fairing or something on here. So I'm going to go hop onto the computer, throw something on the printer, and we'll go check it out here once we're done. Kind of looks like an anchor. Alright, so we popped this thing off the printer, and holy crap, how did this thing get so dirty? I was gone for a day. Oh, one sec, let's clean this up. Oh, that's not clean, but it's cleaner. Let's show you what we got. Was that last scene in there just purely to test and see if I'm capable of doing that whole jump edit with the clap thing and be with the cool kids? Maybe. You decide. But anyway, what we have here is our first kind of positioning piece. Try and figure out if we like where it sits or not. For our control scheme. Control scheme? That's not what this is. For our cluster, our instrument cluster. And it's not a bad spot, to be honest. It's maybe a little annoying with the clutch cable right here, but everything else is pretty good, except for right down here. You can see it hits right here with our, what is that thingy called? Our actual key assembly for turning on the motorcycle. Now we could get rid of the key assembly, but I don't really feel like doing that right now. That's maybe another time, another modification. I'd like to get this thing semi-running. The other thing it does is it actually routes the throttle cables between the mounting points for the control cluster. And the idea here is that if you mount the cables down this way, we get rid of that pinching we were seeing right up here between the key lock mechanism and our mounts. So, and it looks like we have pretty decent results in trying to control that. But because we accidentally broke some of the mount, this thing's a little bit flimsy. So what we're going to do is swap it out with our new mount checkout piece, which is this one. Okay. Too lazy to get that. Extendable magnets for the win. Alright, Alright, so we've got it assembled, and there's already a couple things I was looking at even before we assembled it that I knew was going to be a problem, and this is just worse than I thought it was. These headlights are too low, but this is kind of how we have it set up. Hold on, I didn't check the gauges. Oh, that's much better. So one of the things wrong with this first gauge set is that this 3-hole pattern here, here, and here is what mounts this, and the gauge was like tilted. So I adjusted it here, and that's much better, and then I made this small enough that the actual rubber mounts can stick through. So this thing is mounted like it would be on a normal piece of like 1/8" plate, or I'm thinking we might try and 3D print this. So we'll see if we can manage that somehow. But problems have arisen. And this was kind of going to be obvious to me before I got it, and that's this. This whole assembly is too low. It looks pretty cool. I actually kind of like the look, sort of. This cutout I made here is too low. But this whole assembly is, well, too low. Because this bottom light, which I had intended to be like the headlight or something, is actually rubbing up against the horn shroud here. And it also gets pushed out of the way because the horn shroud is attached to the swiveling part of the triple tree here. So that gets moved in and out, and it's really not great, first of all. So we'd either have to get rid of the horn shroud or move this thing around. And I'm kind of a fan of moving this up some. I think it would do a lot to kind of centralize our wires kind of away from the rotating pieces. And this sort of hoop we have going here is a little bit too extreme than necessary. So I'm going to pull this off real quick. This bottom piece here. This bottom headlight. This was the headlight version of our setup. Okay, so we pulled the headlight off, and you can see there's a couple things going on here. One, this is too low down here, so I'll try and get a shot down here, but this ring that holds the brake line in place that runs from here to the left side caliper on the far side of me here is hitting the bottom of this bracket. Now this bottom of the bracket wouldn't need to be there normally unless it was trying to support half of this bottom headlight, which we already know hits this shroud. And this shroud likes to rotate, so we need to move this up anyway. So that should be able to get rid of by moving up the headlight. But behind this, we see we have huge amounts of clearance on the back side of our key here. So that's not going to be terrible at all to try and... Oh, we've broken it. We broke our mount, everybody. That's expected. Especially with the thin pieces we got going on here. If we take a look at this, this is kind of nice. This is a pretty nice height. Maybe I'll just bring this back in a couple inches, this backside here, and bring this, essentially move this whole headlight assembly up one set, and then adjust these holes, because these holes are not perfect. There's some problems with them, and we need to adjust that because they're not positioned great for our headlights to actually be sitting in the middle of them and rotate around like they're supposed to be able to. So we'll have to adjust some of that. But to be honest, I don't think this style of mounting fixture, this sort of flying wing TX style, is really where we're going to end up. I think we're going to do something a little bit more traditional housing style. So we're going to go back to the drawing board and try and get a better solution that hopefully doesn't fail printing 3 times in a row. All right, everyone. So the newest mount is on the printer and printing. It's already failed once, but hopefully we figured out the support a little bit better this time around, and it'll go better. But you may be wondering, why is the front end back on this bike? You don't want this. And in truth, I don't really want this on this bike, but I wanted to do some testing first before I threw it away just to validate that our new setup is at least moderately safe or relatively close to what we're leaving off of with this thing. So I've taken a bunch of trips in this bike, and I've taken a bunch of night riding in this bike. So I'm fairly happy with how the lights work on this bike. So if we can get relatively similar results out of our new lights as we do on our old lights, then I'll consider that successful. So to do that, we actually reinstalled our lights and the mount, not everything else that went with it, so that we can actually just take a look and film what it looks like in the dark with these things on, both in regular and in high beam mode. And then when we get our new LED mount up, our version 3, we'll check those out in the same way once we're fairly happy with the fitting and we can see what's going on. So first things first, let's turn off all the lights and check these things out. All right, don't trip and die. That light is annoying. Okay, that's better. Now, we're gonna do this real scientific like. We're gonna turn off the lights and then turn on the lights. So, off the lights, and then first is gonna be our driving light. Oh, helps to hook up the headlights. Try this again. Headlights. Okay, reasonable. You get reasonable sort of coverage, and the best light is straight ahead. And then high beams. So high beams are here. Light is definitely more solid, right? You can see that. How that's the low regular riding light that you would pretty much normally use for lights. And then you get your high beams. So we get a more solid, clear line of light, a little bit higher, noticeably brighter at the edges here. So I don't know if you can see me on this, but our light, which is right here, is noticeably brighter here at the edge than it is down here, but it's mostly focused ahead in a projection. So this is what the regular lights look like. So now when we cut everything apart and put it all back together, we'll have an idea of what the new lights look like. Alright. So we've left this on because I want to explain a little bit of it's not a problem, but this is a struggle with a lot of older headlight systems. Modern headlights, we're talking about our Ducati over there. Hello, Joseph. How are you? Want to come say hi to the people? Yeah? No? Just gonna hide behind the bike? Doggo interruption aside, the next the next hurdle we need to go over with putting on the new headlights and getting everything set up is actually sorting out our relays and our connectors. So, let me go get the old ones. So not prepared today. So this was our version 2 mount. I broke it moving it around for measurements. But our headlights do not have the stock Yamaha R6 headlight connector. This is an H4 connector, which means it's got three little prongs on there. We'll get some close-ups for you. These prongs lead to the ground for the low beam headlight and for the high beam headlight. Now, most lights nowadays don't come with this style connector. Most modern lights, they actually run 2 sets of lights and they'll each have 2 wires. These LED lights are similar to those. They use a DT style connector, which means we're going to have to adapt these style of connector to this style of connector. Luckily, the LED sets we got came with bare pigtails with the male side of these connectors. So we just have to wire these into the bike, and then we can connect and disconnect. This presents a couple problems because this bike is set up the way it is. First, you've got to find out which of these goes to which thing. And this bike actually has two different sets of lights. Second, comes with the behavior of these lights. So, I'm going to go put this back in because it's on your side, so you might see it a little bit better. With these three-prong lights, there's a couple ways they're inside, but this specific light, the bulb actually has two little bulb filaments inside of it. So it has a low beam bulb filament that is less light output, and then a high beam bulb filament, which is higher light output. And when you turn on your bike, right, see here's the lights, headlights are on, and I go click this thing. So you'll watch, there is a quick second where there's no lights on and then the high beams come on. If I flip them back, lights off, lights on. What's actually happening here is the bike in all of its electrical setups, which is basically run through these two things here, is switching between the two filaments inside the light bulb. This is fine, but it's not really what I'm looking for. What I want out of my bike is something that's a little bit more standard on modern cars and motorcycles like my Ducati over there. So on the Ducati, what will happen is you'll turn on the bike and the regular headlight will come on and your daylight running lights and everything else. And then it has the high beam switch that will add an additional light for a high beam. That would be ideal here because in my case, the hope here is that I get to leave my headlight on the entire time, and then when it gets dark or I want better vision around, I turn on the high beam, which is a floodlight, which will give me much more view, a much more expansive view, and hopefully a little bit of a deeper, more full view of everything around me, without getting rid of my headlight beam. So, doing that means we have to adjust this behavior, and that behavior comes in right here. So these things hanging off right here are called relays, and relays are essentially just fancy electronical gimmicks that incorporate two circuits. One circuit is a switching circuit, and one circuit is the actual power circuit. So the switching circuit exists to determine whether a switch, it's kind of in the name, it exists whether to tell a switch whether to stay open or closed. And whether that switch is open or closed determine whether power flows through the other circuit, the power circuit, to the thing that's down the line from the relay. If you have, so there's three position relays, there's other types of relays. In this case, that's how these relays work. It's very simple, and they do that because, I mean, these bikes don't need to be super complex, and this was before the age of like electronical everything on these bikes. So this bike has a relay to control the low beams and the high beams, and when that gap goes on, what you're seeing is this is switching off. This is specifically the low beam, and this one is switching on. This is the high beam relay. So just to show you what happens, I'm going to go pull this high beam here. So now this is always open, which means the high beams cannot come on. Yeah, it's the yellow. That's high beams. So if we turn the bike back on, see low beams, cool. Flip the switch, nothing, right? Flip the switch back down to regular lights, our lights are back on. Same thing happens if we disable this relay. So we go pull this relay, which controls the low beams. Switch is on, nothing's happening. Flip on the high beams, and they're here. I would like to keep as much stock usability as possible. We really need to deal with these relays in a way that makes sense to get the behavior I want. So instead of the switching behavior, I want the low beams to stay on all the time and the high beams to switch based on the position of our switch up here on our control pods. This is actually not that bad. What you need to do then is figure out which set of lines running into your relays are the power lines and which one's the switching lines. You can do that in a couple ways. There's the easy way, which is pull up the manual and read up the pinouts and figure out which ways go what. If you're used to looking at these are pretty easy to read. And I did that for this, but you can also do it a different way, and we're going to see if I can pull this off real quick, just for proof that I know what I'm doing. So, do it a different way, with a multimeter. We're going to do a voltage check. So we pull our connector here, and we put our ground on the ground, which in this case is the black wire. It's typically going to be the black wire for you and everybody else. And we're going to put our power wire, the red wire, on what I think is the power wire. If I was looking at the harness, there's two power wires. There's two wires that are common colors between these two. The red and yellow wire and the black wire. Black wire is typically ground, so when you're looking at this relay, you think, okay, the red and yellow wire is the wire that's probably the power side of the circuit. So, if you want to check to see if that's the power side of the circuit, what you do, I've pulled the low relay here, so we can turn this on and check, put our ground in the black, and check the voltage to the, oh gosh, turning things on would be nice. DC voltage, not millivolts. Volts is fine. No, should be around 12 volts, I do believe. So you jump the black wire and your suspected power wire, and with power on, that should be about 12 volts. The other thing you can check is the switching wire. So the switching wire here is this white and green wire. So you put your ground on the ground here and your power on the switching wire, and with that closed, there should be voltage. Now, if we flop our key here, lights are on, which means this relay is working, this one is shut off. So, our voltage to our power wire should remain the same, because voltage always runs to the power wire. If I can get it to read properly. Yeah, okay. So, with the these lights on and this relay theoretically turned off, right? What we have here, if we jump the power wire again, we're seeing 9 point something odd volts, which is fine. What we're seeing there is the headlight draw of the high beams here. So that's the voltage change we're seeing there. But if we go check the signal wire volt, that should be 0. That essentially the power is cut off, and as we do it here, the voltage is in fact 0. What that tells us here is that we've confirmed that this black is both the ground for everything. That's how we're checking voltages. This red and yellow wire is our power wire, so that's the wire that runs straight to the headlight fuse and to the battery eventually. And this white and green wire is the signal wire. So that wire is charged or has voltage running through it when the switch is in the position to activate that light. So in this case, our signal wire is the white and yellow wire on this high beam. So right now, there's voltage running through this white and yellow wire, which closes the switch, allowing this red and yellow wire and this black and yellow wire to connect and send voltage to the headlights. So, how do we get the behavior we want out of these headlights? Well, it's pretty simple. What we have to do is always have this red and yellow wire connected to this wire here, which is the wire that connects to the low beam side of these 3-prong connectors. That's the black and blue wire and this headlight. On the high side, the black and yellow wire is the high beam side connector. So we just have to make sure that those are always connected, and then this signal wire is really not necessary. So let's figure out how we're going to do that. All right, so getting in here and jumpering these two wires together, there's a couple ways to do it. I'm going to try one way, and if it fails, we're going to go with the permanent way. The permanent way is actually just removing these two wires right here from the connector and connecting them. That will permanently connect your constant power wire here to your power supply to your headlights for the low side beam. If you wanted to permanently connect your high beams for some reason, just do it on this one and connect these two. That pretty much eliminates this thing ever going back to anything resembling stock here like this. I'll do that if I have to, but I do want to try using a jumper and kind of preserving some of this stuff here. So instead what we're going to do is we're going to take, oh, I dropped them. Instead what we're going to do is we're going to take a few pieces and make our own a little jumper wire so that everything runs and we maintain this connection if we ever want to replace it or go to a different style. We don't have hacked wiring on this side of the wiring harness. So our jumper is going to consist of a couple of tiny little pins that fit into the here, and just a short thing of red wire. Red wire because it's power. If we were jumpering a ground, I'd jumper it in black just so visually I knew what was going on. So all we got to do is strip this, hook these on, we'll test it, and then we'll put a little black electrical tape around it so that we kind of protect these wires. All right, and here's that tiny ass little wire. So let's see if we can't get this jumper in here. Something like that. And let's see if the headlights turn on. Hey, see, lights are on. And then here's the real test. We're going to turn this off so there's no power in the system. That's the high beam relay, or high beam relay. So now that it's disconnected, we turn this on. Low beams are on. Let's flip the switch and see what happens. Nothing. That's good. Normally, if this wasn't in and both the relays were in, these would have shut off and the high beams would have come on. If this was out and this was working as originally designed, I'm not going to say intended because obviously this is now working as intended. These lights would be off because the high beam relay is out. So we have now successfully jumped our lights, so our daytime lights, our headlights, are on all the time. Okay, so can you see me? I don't know. We'll just lean in here for this. So we've got this, and I actually went and made some connection saver things here. It's just a couple of dead wires. They're not actually hooked together. Just in the connections here, trying to save the connections as much as possible from any sort of corrosion from generalized moisture in the air and everything, because these ones will be connected and working. These ones just have connectors in them to stop them from corroding too much. I mean, these are gold plated, so it shouldn't be too bad, but decent practice anyway if you can do it. Next up is these. Come on. So this right here is our actual headlight connector. So the back of these headlights are H4. It's an older style of connector. Typically, you don't see it too much on modern cars. Modern cars typically have something like these, which are 9005, 9006. These specifically are universal connectors. But a lot of headlights now that you'll see on your cars are this style of connector. So on the back here, we see 3 different color wires. We see a black wire, which is our ground wire. That's going to be pretty typical. We see a black and blue wire, which is our power supply from the low beam, and that goes to the low beam part of the headlight here. So if this plugs in like this, your ground is on the left-hand side, your low beam is on the top, and your high beam, in this case a yellow and black wire from our high beam relay here, is on the right-hand side. Now, we really don't need all 3 connections from this. So what I'm gonna do is, because we have headlights on both sides, I'm going to actually use the left side over here for our low beam LED headlight, and the right side over here for our high beam LED headlight. What that'll mean is we're going to have 1 unused wire on each side. That's not a huge problem. We can always use that for something else later on if we want to, or like if we wire in another low beam headlight, we won't have to deal with this. We just have to deal with this one and getting a ground going. So that's not too bad. But that means we're getting rid of these connectors, and we're probably going to have to back up on this tape. This is electrical taped to hell and back. That's kind of nice. Where's the edge? Oh, they started out here. Oh no. Just love gummy old electrical tape. But if we're not using this connection, what are we using? We're actually going to use a series of connections, and I'll explain it. We're going to be taking some of the headlight connectors we were cannibalizing way back in like the 2nd episode of this this channel. We were rewiring the headlights from our Project Chrysler 300C from xenon ridiculous setup to a regular halogen style setup, and we had a bunch of connectors that we cut and spliced together, and these are pretty universal style connectors. You can find a lot of resistors if we need them, or similar style stuff with these endpoints, or bare connectors, which we have more of these connectors to go throw in. So what we're actually going to do is cut this off here, wire in a, I guess we'll wire in the male. Wire in the male connection here as a connector here, and then use these female connectors on these bare pigtails from the connector we got from the LED bar light. So the idea is we'll be able to, this side goes to the bike power source, this goes to the LED connector, if I do it right way up, and then this one goes to the LED. Now why go through that? Because I could just cut this off and wire the LED connector in. Well, if I don't currently have LED ballasts, and if I want to order them, LED ballasts, that's xenon or HID terms, I don't have an LED resistor. And I am not certain if I will need an LED resistor for these headlights on this setup. But if I do, I don't want to have to cut apart all this wiring all over again and rewire everything just because I hardwired this into this connector. So if I essentially put a small jumper in between here, what I can do is that when I get a resistor, if I need it, I just open this up and put the resistor between these 2 connections. And it makes it very easy to do that. It also makes it pretty easy to make adjustments to the wiring system and that sort of thing. So that's kind of the plan here, is to do it that way. So we're going to get started on that, and I'll come back hopefully when we have something to show you. All right, So we're the next day because it got late and I wanted to sleep a little bit, and we've made some changes. So previously I had talked about putting a bunch of jumpers in here and making sure that if we needed things like a resistor or something for our lights, that we could get it in there and not have to rewire everything. But then last night when we were testing it, I didn't need a resistor, and we noticed something off. So the spread on the headlight, which is theoretically going to be this one, is not very wide. It's a very focused beam, which I guess I should have expected, but I didn't really expect it to be as focused as it was. And the actual light projection is pretty narrow, which has me a little concerned about usable light. Right now, we don't have it set up in a sort of functional position. It's just kind of sitting up on top of things. Our new bracket that isn't broken will be off the printer in a few hours, I hope, and we'll be able to test the lights then and test their spread. But I was worried about the spread not being wide enough, and I might have to add auxiliary daylight running lights or auxiliary lights to increase the spread during normal driving when I don't want to have the floods on. So I made an executive decision and converted to a completely soldered connection. That's this lovely piece of wire that hopefully you're seeing a close-up of right now. Pure manufacturing and fabrication perfection, if I do say so myself. But I went to this, so it shortened up what is essentially a 12-inch extension of our headlight lights, which is going to be really hard to hide in a much smaller front fairing. And it also gave us some other options. So instead of using the left side headlight, this one, connection, for just low beams and leaving the high beam connector off, and the right side headlight for just high beams and leaving the low side connector off, I've connected both the high beam and the low beam, or the driving light and the fog light, here on the left hand side, and given myself options for the right hand side. If I want to add lights, I can add more high beams, I can add more low beams, and I can do that without having to mess with this side, because this side's good and this side's the way I like it. So now is the kind of final test. So we're going to hook them up. Let's see, that's headlight, and this is, I'm going to have to label these. This is terrifying. That's blue, so this is the headlight, I hope. And then, where is this other one? It's over here somewhere, maybe? Oh no! Don't fall. I need you to not fall, thank you. This is a demonstration. Hopefully this works. So, unless I swapped the connections around, I'm going to turn this key back here, and this light should go on. And then when I flip this high beam switch, this bottom flood should go on. And this light should stay on for good projection. That's the idea, anyway. Okay, good start. And hey, success! I hope that didn't wash everything out there, but looks like our lights are now wired correctly. And we have the desired behavior. Now we're just going to wait for our new mount prototype thing to come off of the printer, and we'll sling these things back on here and point it out into the dark and see how the lights go. All right, we got our headlights in their final-ish position, I think. At least this is where I like them. And everything works. I am going to admit it has been a frustrating few days, week. How long have I been working on the project? Way too long. This mount bracket fixture assembly that I've been playing around with, 3D printing it, has steadily gotten harder and harder to print. I think this one is even pretty much junk. It just, all the stuff that was in place to hold the headlights in place were there, so I've used it to check out their fit anyway. But you'll notice the gauge assembly is not on there because I printed it in 2 pieces, and where it's supposed to hook up, which is right about here, there's a bunch of stuff wrong with the print. So yeah, it's been a frustrating summer week-ish trying to figure this out. But we're here, and we have a pretty good idea that this is where we want everything. Now, we may not make it exactly this material. I'm not exactly certain what the final build material of this is going to be, but this location here, and then maybe putting our controls somewhere back up in here, I think is where we're going to end up, just so we can, or our instruments back up in here, is kind of where we're going to end up, and hiding a bunch of the wires somewhere in here. This is the wiring is going to be a real pain at the end, but yeah, we're mostly there, and I haven't pitched the bike and burned it out of frustration, so that's a bonus, right? I think we're going to cut it there though. So thanks for watching, everyone. My name's Andrew. This is a Make It and Break It YouTube video. Like, comment, subscribe, do all the YouTube things. And don't forget to hit that bell icon so you get notified when we put out a new video. If you like some of the t-shirts and sweaters I wear on this channel, check out the Teespring link down below. We've got a few different versions of our logo sitting up there. Shirts are really awesome and comfortable. I wear them pretty much constantly because I film in them. And that's it. I'm done rambling. So thanks for watching, and I'll catch you later.